For this section, we're taking a look at volume, mainly intensity. We have three formulas. I put them down here. Intensity is equal to energy divided by area and time. The idea here is that the loudness greatly depends upon the energy that goes through a certain amount of area. So if you picture, like here's my area cross-section of, say, a rectangle, and say I have a speaker right here, and waves are coming out of that speaker. The more waves that pass through that area, the more intense that sound is. So intensity is directly related to amplitude. So we're looking for amplitude, the amplitude of the wave. And remember when we did waves, here's a wave, poorly drawn, and here's the midline of that wave. Our amplitude would be these vertical lines I'm drawing here, how tall they are. So the taller, the more intense, and the more that go through an area, the more power that goes through that area, I should say, the more intense the wave is. I shouldn't have said that the more waves that go through, because that would be frequency. It's just how much power they're carrying as they go through that area has to do with intensity. All right, so we have a couple practice problems from your notes. A speaker outputs 0.2 watts of sound through a square-shaped area of 1.5 meters on each side. What is the intensity of the sound? So really this formula down here in the corner, the E over AT, energy per time, this unit right here is actually another way of saying power. And power is measured in watts. So I'm going to use the second one down here, power over area. Now I'm told that it's a square-shaped area. So with 1.5 on each side, I need to calculate the area of this box. And area is base times height. So I'm going to do 1.5 times 1.5 because that's both of the sides of my square. And I get 2.25. So my intensity is going to equal 2.25 is the area that we're passing through, and our power, we're told, is 0.2. So we have 0.2 on the top. So 0.2 divided by 2.25, and we get an intensity of 0.089. And there we go. That one's done. Let's take a look at the next one. We're going to reverse things up a little bit. So what area, so now we're looking for the area, so basically the size of our speaker or whatever, does a sound with an intensity, so here's our I, of watts per meter squared, pass through if the power source, so here's our P, is 0.3 watts. So again, we're going to use this formula down here. I equals P over A, and our intensity is 0.08, our power is 0.3, and A. So in this case, I'm going to cross multiply, so I'll get 0.08A equals cross multiply 0.3, and now divide both sides by 0.08, and that will give me my area. So 0.3 divided by 0.08 gives me 3.75 for my area. That's going to be meters squared. So this is a fairly big area that we're passing through. If you think about it, 1 meter or 2 meter by 2 meter if I was talking about square. So this is taller than a person area on both sides if it were a square. But we don't have know nothing about the shape. We just know the area that we're passing through right there. All right, we got one more, and this has to do with the fact that as you get further from the source, the sound decreases in intensity. So we expect the further away, the lower the sound. So this was given to us in scientific notation in our notes, but I changed it a little bit so it would just be a little bit easier to follow. So we have I equals P over pi r squared. Now, this is a sphere right here at the bottom, the formula for a sphere. So we're accounting for, I should say, the surface area of a sphere. We are accounting for r being our distance from the source. Could I spell that wrong? Okay, so I is given to us right here. This is our I. And this right here at a distance of 50, so this is our R. So we're 50 meters from the source, so that's why this is not intense at all. We are very far away. So 0.00000, want to make sure I get the right one. 1, 2, 3, 4, 5, 5 zeros. 35 equals power, that's what we're looking for. 4 pi r squared, that's going to be 50 squared. And then we could cross multiply right here, and that'll help us get this. So in the end, we're going to get 0.00035 times, when we cross multiply, 4 times pi times 50 squared. That's going to equal our power. So I'm going to type that all into the calculator. So 0.0000, one more it looks like, 35 times 4 times pi times 50 squared. Okay, so our power is 0.11. Of course, there's a bunch of different questions that we could ask to solve for any part of these, whether it's area, intensity, energy, radius, the distance away. But it's basically plug in the numbers and solve.